All right, students, now I'm going to be talking about Z-table, the applications of Z-table. So this is my Z-table. This is another name for that is standard normal distribution table. Okay, here my values. Okay, they are from minus 3.1 to minus 0.1, and my each one of the values right here, each one of the values they represent the area to the left of my Z-score. That's what that is. This one right here represents my z values. Okay, my z values from zero point zero. Okay, zero point zero to plus 3.0, and again the area represents to the left of my z-score. So this is what it represents. Each value represents this area right here. Okay, that's what that is. So each one of these numbers right here, they represent the area, and each area is nothing but the probability that your z is less than that this particular number right here. So let's start with the question. Let's say you have an annual rainfall. Okay, annual rainfall at a particular geographic location is modeled as a normal random variable with a mean value of 60 centimeter and standard deviation of 20 centimeter. This is another way of saying that your distribution of your rain is basically as this normal distribution. That's all it's saying. So now the question is, what is the probability that this particular year, the average rainfall is going to be at most 80 centimeter? That's the keyword, at most 80 centimeter. So let X represents the mean rainfall. Okay, let's say this is your mean rainfall, and you have to find that the mean rainfall is at most 80 centimeter. That's your question right here. That's your problem statement. So this can be written as probability of X less than 80, because when you're saying at most, that means your value should be 80 and under, right? That's what the word at most means. So probability of X less than 80, you have to find that. So the first thing we do, we convert our normal random variable to a standard random variable. And the way we do this thing is using this formula right here. This is the formula that I use to convert your normal random variable to standard normal variable. So my X equal to 80, and so let's substitute your value. Okay, now you know your X, you know your mu, you know your sigma. So your mu is 60, right? Your mu is 60, which is given to you right here. This is your mu. Now, what is your standard deviation? Is 20. Okay, that's given to you right here, standard deviation 20. And then you know your X is 20. Sorry, X is 80. So 80 minus 60 divided by 20, and the answer comes out to be 1. So X equal to 80, that means when X equal to 80, that's mapped to Z equal to 1. So now the problem statement becomes probability that X is less than 80 is same as probability that your Z is less than 1, because X equal to 80 has mapped to Z equal to 1. So now you know how to find this one, right? You can use your standard Z table, and you can see the probability of Z less than 1, which is this right here. Okay, this is this area right here. This you can find that using your standard normal table or your Z table. So Z is less as 1 right there. Okay, and this is 1.00. So you're gonna come over here, this, and this actually is this one right here, 0.8413. So that's your answer. So probability of Z less than 1 is 0.8413. This represents the probability, that the chance that the average rainfall is going to be at most 80 centimeters this year. Another question, something similar, but this time and the question is that the annual rainfall at a particular geographical location is actually has the same normal random variable with the same value of mean, 60 centimeter, and your standard deviation is same. Now the question is, what is the probability? Okay, what is the probability that this year the average rainfall will be at least 80 centimeter, not at most, but at least? Well, I'm following the same thing I'm following the same pattern I did in a question before that. So, but except now I'm saying the probability of mean rainfall is at least 80 centimeter. At least means that it should be X should be greater than or equal to 80. All right. So first you map X equal to 80 to your Z value. Okay, I'm doing the same thing that I did in the before question. I calculate my Z value for this X value. This is the formula you use. Okay, I know my mean, I know my standard deviation, substitute your value, and my Z comes out to be 1. So my X equal to 80 has mapped to Z equal to 1. So now your question, X probability of that X greater than 80 becomes probability of Z greater than 1. Now, we know that this probability, okay, and the total area in your under your curve is always going to be equal to 1, and we know that this one right here, okay, this area is the probability of Z less than 1. Okay, so this one right here is going to be 1 minus this probability Z less than 1. Whatever this answer is, it's going to be that. So this is going to be 1 minus that number. So this is what I'm doing over here. So I'm calculating my probability of z less than 1, because the reason I'm doing this thing is because that's this table, that's the only value it allows you to calculate. You cannot calculate p as z greater than 1 directly. You cannot do that. But you can calculate from your table probability of z less than 1. So I calculate my value and the answer comes out with 0.8413. So this is my value. So once I know probability of z less than 1, this is my 0.8413, and I subtract this number is my 0.8413. Okay, this is my number. So this number is going to be 1 minus 0.8413. Okay, that's what that is, because your total area is equal to 1 always. And that's what I'm doing over here. And my answer comes out to be 15.87, 0.1587. So the probability that the average rainfall will be at least 80 centimeter is going to be 15.87% chance. All right. Okay. Now the question is the average height. The average height of a person is modeled as a normal random variable with a mean of 179 centimeter and standard deviation is 10 centimeter. So what is the probability that a random person selected, okay, you select a random person and his height is going to be at most 170 centimeter. All right, so let's x represents the height. So in this case, the probability of mean height, okay, is at most 170 centimeter is this right here. Probability of x less than 170. By the way, mean does not apply. In this case, it's just a height. So probability of x is less than 170. So in this case, first we convert our random variable to a standard random variables. Okay, I use my formula right here. This is the formula I use, and my x equal to 170 has been converted into z equal to minus 0.90 by using this formula. Okay, and basically I know my this is 170 is my x, my mu is 179, which is right there. Okay, then my standard deviation is 10, which is right here. Okay, and then I substitute my value, it comes out to be minus 0.9. This is how I came with this value. So the probability of x less than 170 is the same as probability of z less than minus 0.9, which is same as 1841, 0.841, which is this value right here. Okay, I'm actually just using my standard table to calculate my z, my this area under the curve towards the left of my z value. Okay, now the average height. The average height of a person is modeled as a normal random variable. Same question as the before, except now I'm saying that if you randomly select a person, okay, what is the probability that his height is going to be at least 170 centimeter? So I'm doing the exactly same thing I did before question. Now my question, now I'm basically finding the probability that his height is at least 170 centimeter. So x is greater than 170 centimeter. So first we convert our normal random variable to your standard random variable. Okay, how am I doing this thing? I'm using this formula right here. This is my equation. You're mapping your x to your z value. You're taking your x value, you're finding your corresponding z value. And this is the equation I'm using. So 170 minus 179 divided by 10. Okay, and my answer comes out to be minus 0.9. Minus 0.9. So now your question is probability of x greater than 170 is the same as probability of z greater than minus 0.9. Now, but the problem is we cannot find this. We cannot find this directly from the table, but I can find this value, right? So I know my probability of z less than 0.9 is 1841, 0.1841. So once I know this value, okay, which is this one right here, this is my value. Once I know this value, okay, this value, okay, this particular value right here, this is going to become 1 minus 0.1841, right? That's what that is. Okay, that's what will represent this area, and that's what I'm doing over here. So I'm saying 1 minus 0.1841. So I do my calculation and my answer comes out to be 8159. That means the probability that a random person selected height is going to be at least 170 centimeter is 81.59% chance. It's 81.59% chance that his height is going to be at least 179 centimeter. The average height in this question, what's given to you is that the average height of a person is modeled as a normal random variable. Okay, the mean value is 179 and standard deviation is 10 centimeter. In this case, they're asking you that if you randomly select a person and what is the probability that his height is going to be between 160 and 170? That's your question. So same thing as before, your x is represents your height, and in this case you have to find the height. Okay, the height between the height of the person is between 160 and 170. In other words, you have to find the probability that x is between 160 and 170. So first we convert both these values, 160 and 170, convert them into your z values. So if my x1 is 160, convert into z1. Okay, it comes out to be minus 1.90. You can do that. So let me do one for you. Your z1 is going to be equal to, okay, x1 minus mu divided by sigma. And what is my x1 in this case? 160. Okay, 160 minus mu. What is my mu in this case? My mean value is 179, right? 179, which is right here. And then my standard deviation is 10, which is right here. All right, and you substitute this value, and my answer comes out to be minus 1.9. Okay, so for this x1, okay, my z1 is minus 1.90. For this x2, okay, my z2, it comes out to be minus 0.90. So I know my z1, z2. You have to find, okay, remember the question is this: you have to find the x between 160 and 170. All right, so let's find this one first. Okay, let's find your probability of z less than minus 1.9. Well, using your z table, this will give you 0.0287. Okay, that's your answer. This one represents this area. Okay, this is the area. So this one right here, the probability of z is less than minus 0.9. This will represent this area right here, okay, this one. So you have to find the area between z1 and z2, right? So this is your z1 area, this one right here is your z1, and your z2, which is this right here, this would be your z2 area. And we just find this answer using a standard using a z table or standard normal distribution table. So you know your a1, you know your A2. So what is the area between A2 and A1? That represents the probability that your value is between Z1 and Z2. And you can find that using A2 minus A1. And this is exactly what I'm doing over here. I'm actually finding my probability that Z is between minus 1.9 to minus 0.9. I'm subtracting the bigger area from the smaller area, and that's going to give me this answer. So it is 15.54% chance that a randomly chosen person height is going to be between 160 and 170 centimeter. Okay, last question. Let's say the human body temperature, okay, it follows a normal distribution. Let's say the human body temperature follows a normal distribution with a mean value of 98.6 degree Fahrenheit, and your standard deviation is 0.7 degree Fahrenheit. So what is the probability, okay, that a randomly chosen patient's temperature is going to be between 98 and 99 Fahrenheit? So that X represents your temperature. In this case, the problem statement is find the probability that your temperature is going to be between 98 and 99. In other words, your probability is going to be x is greater than 98 and x is smaller than 99. That's your question. So first we convert, just like I did before. I convert my x1, which is my 98 right here, 98 and 99. So my x1 is 98 and my x2 is 99. I map them to my z1s, okay, z1 and z2. And how do I do that? I use this formula right here. Okay, so I'll do one for you. Let's say I'm going to do this time z2. So my z2, okay, is going to be equal to x2 minus mu divided by sigma. Now my x2 is in this case 99 minus mu. Mu is your mean value. What is my mean value? Well, you can see that mean value right there, 98.6. 98.6, okay, divided by your standard deviation. Standard deviation is 0.7. 0.7. And you solve this thing, and the answer would be 0.57. All right, 0.57. This is how you come with 0.57. This is how you come up with this value. Okay, so I have mapped my x1 and x2 to z1 and z2. And we know from our table, okay, that the probability of z less than 0.87 minus 0. Probability of z less than minus 0.87 is equal to 0.1949. Okay, this is given to you. This actually you can figure out from the table. So this one represents this area right here. Okay, this is my z1. A probability of z1 less than actually probability of z less than minus 0.86. Now probability of z less than 0.56, or sorry, 57 would be 0.7157. This again from a standard normal distribution table, from a z table. This represents this area right here. So the probability that your z lies, okay, between minus 0.86 and plus 0.57 would be this area right here. Okay, this area in between. You have to find this area. And this area, you can just by looking at the diagram, this visual picture, you can tell that the area is going to be equal to A2 minus A1. Okay. And this is exactly what I'm doing over here. I'm actually doing my A2 minus A1. All this calculation is doing A2 minus A1, and the answer comes out to be 5208, is 0.5208, which is 52.08% chance that a randomly chosen person's temperature is between 98 degree and 99 Fahrenheit.